Okay, so we're going to talk about non-right triangle trig because essentially everything you've done with trig has involved a right triangle. So what are we talking about? We are talking about solving oblique triangles, which are triangles without a right angle. Oopsie. Yeah, triangles without a right angle. So if you think about any triangle, it could be made up of right triangles. So if we know how to do trig with right triangles and we put two right triangles together to make a non-right triangle, then we can do this. It's not so bad. Because, I mean, look at it this way. If we look at a triangle like this, let's say, technically you could see it is two right triangles stuck together. So those properties can be applied, and these formulas have come up with. So we're going to do two topics in chapter 6, and that would be the law of sines and the law of cosines. Both of them can be used to solve non-right triangles. And when I say solve a triangle, that means find all three angles and find all three sides. That's what I mean to solve a right triangle. So let's start with section 6.1, which is the law of sines. And as far as which one's easier to remember, it is the law of sines because it is a really, really simple formula. All right, actually, we're going to slide right back to our lovely triangle and we'll use that. And the law of sines is basically if we label this A, B, and C, the opposite side, so that's angle A, angle B, and angle C. This would be side A. We're going to use lowercase. It's opposite. Side B would be down here, and side C is over there. So your formula for law of sines is A over sine of A. Is it proportional to B over sine of B and C over sine of C? Okay, and you can pick any two of those to set this up. I'm not going to go through the proof on how this works. But in order to do this, in order to use this, you have to have either two sides and an angle or two angles and a side. So you're going to see that, like when you did geometry and there was angle, side angle, side, all those things, you're going to see that not all of them can be solved using the law of sines. This formula is definitely the easier of the two, but like I said, it's not universal to every triangle, so it's only to certain ones. So anyhow, also these can be all written in the reciprocal form, which would just be to flip them all. Just make sure the side is on either the top or the bottom, and the angles are in either the top or the bottom. You can't switch them back and forth. All right, so let's hop right into this and let's solve a triangle. Okay, two angles and one side. Let me draw it out for you. If you're concerned about the noise in the background, I'm running the dishwasher, so sorry. All right, let's see. We'll call this A. We'll call this C. And C is going to be 102.3 degrees. And this is B, and we know B as well. This is 28.7. And we also know this is side C, this is side A, this is side B. We know side B is going to be equal to 27.4 feet. All right. So, can we find the rest of them? Yes, we can. Now, what you're looking for in the law of sines is something to be the same. So you see how we have angle B and side B? You need that. And then you'll have one blank, because if we look back at the formula, you have to have one of these ratios completed. So we have angle B and side B completed, or sine B. No, angle, I said it right the first time. Anyhow, we have this ratio completed, so we'll be able to plug that in right here. All right, so let's do B over sine B is equal to C over sine C. And let's just plug everything in. So B over sine B, let's see, B over sine B. Oh my goodness, wow, sorry. My brain just went blank for a second. B over sine B, 27.4 feet over sine of 28.7 is equal to C, which we don't know yet, over sine of 102.3. So there you go. Now all we would do is cross multiply these, and actually these are actually, they're all values. We won't have to do anything crazy here. So 27.4 sine 102.3 is going to equal C times sine of 28.7. So you can see to solve for C, we're just going to have to divide by sine of 28.7. And then we'll have C by itself. So, not too bad. We can do that pretty easily. Let's figure that out. So 27.4 times sine of 102.3 divided by sine of 28.7 will give us C to equal approximately 55.8 feet. Once you do the math for that. So of course we can write that in. All right. So we have two sides and two angles. So now the issue here is we have B and side, we have the side B and angle B. We have side C, angle C. In order to get A and A, we need one of these. Can we just get them? And if you forget, we could get angle A just by taking 180 minus 102.3 and minus 28.7. So angle A is going to equal 49.0. And now we can set this up once again, and we can get side A. Now I want to always go back to the original amounts. I don't want to use this because I rounded this, so I want to go back to these originals. So I'm just going to swap out this for now A over sine A, and I'm going to set that up and solve it. So B over sine B is still 27.4 over sine of 28.7 equals, this time, A over sine of A, so sine of 49.0. And now we can, once again, cross multiply. I think you know that part. I'm not super worried about that. But cross multiply and solve it, and you should get 43.1 feet. Okay, so that's how you solve a triangle. You find all of the angles. You find all the parts. So this was two angles and one side. This was angle, angle, side. Okay. No matter what, when you're given two angles, you can immediately find the third angle. It does not matter, because we know that the sum of the three angles in a triangle will always sum up to be 180. Wow. Okay, so, yeah. If you get this, by all means, jump right to the end. If you are stuck, then I'm going to do another example right now. So stick with me. And once I draw out the triangle, you might want to pause it and then try it out by yourself and see how far you get. So the next one we'll do is, let me draw out the triangle for you. This is A, this is C, this is B, which makes this A, C, B. All right, and the values that we're given are, this is going to be 98 degrees, so this is 43 degrees, 98 degrees, and this is 22 feet. All right. So right now we have B, C, and A. So we have three different letters, so we can't set up that ratio. But if we get angle C, then we have angle C and side C, then we can do some work there. So anyhow, simply subtract 180 minus 98 minus 43, and we're going to get 39 degrees right here. And now we can set up some ratios. So let's do side C over angle C. So 22 feet, and then the angle is 39 over sine of 39 degrees. So side C and angle C are going to create the first ratio. Let's solve for A first. So let's do A over sine of 43 degrees. All right. So let's see what's going to happen here. Anyhow, cross multiply and divide, and we will get, so let's see, 22 sine of 43 on the left, and then a sine of 39 on the right. Divide away the sine of 39. And once you just calculate all that, we're going to get a is equal to 23.8, or let's just round it to 24 feet. Okay? Anyhow, if you go through and let's say we wanted to find side B, we would set up the same exact thing, except instead of A and sine of A, we're going to do B and sine of B, and we would use 98 degrees there. And it'll give us the other side. So I think that you guys can handle this. It's really not so bad. You know, you just kind of have to, you know, test it out, see how it goes. It's not bad at all. Anyhow, I'm going to give you some basic ones just to try out. So on page 416, I want you to solve these triangles. I have number 1, number 3, not number 5. We'll skip that one for now. You could do number 7. Yeah, that's probably it. Just do those 3. That's good. Yeah, just use the basic formula. Now, there is a case where, like, there's like a no solution, and it has to do with your given values that don't actually form a triangle. I'm going to show you that tomorrow. So just start with the basic ones. These ones should all work. So check them out, try them, see how it goes. Let me know if you have any questions.